Hello everyone, my name is Huangyu Wang, and I'm going to talk about our work compressing models with few samples, mimicking then replacing. The aim of our work is to improve the results of compressing models with few samples. Data privacy issues are more and more important nowadays, so we try to consider compressing models with only few samples. There are many data-free or few-sample work about model quantization, but a lot of work based on network pruning, so we focus on fine-tuning pruned models with only few samples. If we fine-tune pruned models with few samples, it's easy to overfit. Therefore, recent work tried to recover the representation abilities of the pruned models layer by layer. They believed if every layer was recovered, that the whole network can be recovered. That also means we should make sure the pruned layers had the same dimension as the original layers. However, these layer-wise error reconstruction methods will bring error accumulation and also introduce the restriction to models' structures. We got a lot of way to prune a model. As you can see in this figure, remove the residual connections will cause dimension mismatch problem, and also some pruning methods try to drop the entire layer or entire residual block. Just imagine if there is not only n layers in pruned model, while we have n plus 1 in the original model. How can we fine-tune the pruned model layer by layer? So these layer-wise reconstruction methods cannot deal with these situations.
So we need a general and simple framework for this few sample compression task, which can simplify the training procedure and can support different pruning schemes.
About our method MIR, the idea is really simple. We try to fine-tune a pruned feature extractor to make it produce the same output as the original feature extractor. So the first step is to prune the model. We are not focusing on how to prune, so we use the L1 norm-based method to prune the model. It's a data-free pruning method, which means no training samples used. Given few samples, the original model and the pruned model can extract features FO hat and FP hat. To mimic the extract features, there are many ways to make the features of pruned models similar with the features of the original models. We try to make it as simple as possible. We make every pixel of the features FP hat the same as the features FO hat. That means an element-wise mean square error is used in our mimicking period.
After we get a compact feature extractor that can produce the same outputs as the original one, we just use the classifier of the original model instead of tuning it, which can avoid overfitting caused by tuning the classifier with only few samples. One step further, most of the modern models have a pooling layer before the classifier. The pooling layer is used to filter out noisy and aggregate the information, but it can also filter out details. So we try to mimic the features before the pooling layer, which brings no extra computations, but brings significant improvements. About the experiments, we compared our method with naive training methods and layer-wise reconstruction methods. We randomly sampled few samples from the training set. To compare fairly, we fine-tuned our MIR 2000 iterations with batch size 64, and all the results were reported with 5 trials. As the results shown, our method outperforms others with a large margin, and MIR before brings significant improvements compared with MIR after. And also, to prove the generality of our method, we compared our methods under different pruning settings and different pruning rates. The results have shown that our method is general to use under different settings.
About more experimental results, please refer to our paper. That's all. Thank you for your listening.